A poster is to have an area of 180 square inches with a 1-inch margin at the bottom and sides and a 2-inch margin at the top. What dimensions will give the largest printed area? So now that we've read the problem, we'd want to draw a picture so we can see what's going on. And we need 1-inch margins at the bottom and the sides, but we need a 2-inch margin at the top. So this needs to be 2, and each of these need to be 1. The poster is to have an area of 180 square inches. So let's give it dimensions x and y, and the first thing we know is x times y needs to equal 180. Now we're interested in the dimensions that will give the largest printed area, so the printed area would be this right in here. So let's express the printed area. So the printed area is going to be y minus 3, because we've got our y and take away 2 here and 1 here, and then it's going to be times x minus 2, because we look in our x direction, we've got 1 here and 1 here to take off to get our printed area. Now I have area as a function of x and y, so let's solve this for y, the connection we have above, and we can substitute that for y here. We now have area is going to be 180 over x minus 3 times x minus 2, and we're going to want to multiply that out. So that looks like that's going to be 180. When we do first times first, we do outers, we get minus 360 x to the minus 1. I'm writing it like this because we're going to be taking a derivative, so rather than over x, it'll be easy to express as a power. Inners are minus 3x, and last times last is plus 6. Since we're interested in maximizing this, we are going to take a derivative and find where that derivative equals 0 and make sure that's our max. So a derivative of a constant, we have two constants here and the derivative of those are gone. Derivative here is a power rule. Power out in front will make that a positive, and then decrease the power by 1. So that's x squared on the bottom because it's x to the negative 2. Derivative here would be minus 3, and we're interested in when that equals 0. So that gives us 360 over x squared equals 3. So x squared equals, multiplying the x squared here and dividing the 3, 120. So now we could square root both sides, and normally we'd put plus minus, but x is a length, so it will only be the positive. So it looks like we have square root of 120, and this is 4 times 30. So we have 2 square roots of 30. If we just confirm that we have a maximum, we could take a second derivative, and that would be negative. If we're interested in confirming that this is a maximum, we could take a second derivative. Now think of this as x to the minus 2. So power out in front, decrease the power by 1. And of course the derivative of a constant is 0. So here is our second derivative, and since x is the length here, that's always greater than 0, the second derivative is always negative, which tells us the graph is always concave down, so our critical number here is a maximum. So we have our answer now. We would need to make the x direction here 2 square roots of 30 inches, which we could get a decimal approximate of that if we needed it. We'll go ahead and leave it in exact form. And then we could find the y if we take, I'll put it over here, 180 over the 2 square roots of 30. So that's going to be 90 over square root of 30 inches. And again, we could get a decimal approximate if we needed it.